Hello everyone, welcome to this quick video presentation that we put together for the Belimo zip controller wiring. We will also be putting together another video showing a live demonstration of the setup of the controller, but for this video we'll just be talking about the wiring. Let's get started. So of course, first and foremost, we want to make sure that we de-energize the unit and lock out the panel because we want to make sure we're always being safe. That being said, we're going to go ahead and talk about the 4 different control strategies for the controller. The first one being single dry bulb. For this one, all you'll need is your outside air temperature sensor. So for this, you can see our economizer is enabled because it is below that high limit. Once it has surpassed that high limit, the economizer becomes disabled and becomes enabled again after the outside air temperature is 3 degrees less than our temperature high limit. Our next option is differential dry bulb. For this, you'll need an outside air temperature sensor and a return air temperature sensor. For these, you have 2 parameters, your differential temperature high limit, and then you're also monitoring your return air temperature. So our economizer is enabled until it becomes higher than your differential temperature high limit, in which it becomes disabled. Becomes enabled again after it's below that 3 degree set point. And it becomes disabled again because our differential temperature is less than 2 degrees between our outside air temperature and our return air temperature. And for order for that to re-enable, the differential would need to be 4 degrees or greater. Our next option is our single enthalpy. You can see here we have our outside air temperature and humidity sensor. So for this one, we have 4 phases. Our first one being our economizer is less than our temperature high limit, so it is enabled. Becomes disabled after our outside air temperature is above that limit. Becomes enabled again after it's 3 degrees less than that limit. And it becomes disabled again after our enthalpy of our outside air is greater than our enthalpy high limit here. Our last one is our differential enthalpy. Similar to our differential dry bulb, you need an outside air and a return air in terms of temperature and humidity. This one actually has 6 phases. Here you see our economizer is enabled. It becomes disabled after the outside air temperature is greater than the temperature high limit. Becomes enabled again after it's below that 3 degree Fahrenheit threshold. Becomes disabled now because our outside air enthalpy is greater than that high limit. It becomes enabled again after it's more than 2 BTUs per pound less than our high limit. And then it becomes disabled again after the difference between our outside air enthalpy and our return air enthalpy is 1 degree or less. In order for it to become re-enabled again, it needs to go up to 2.5 BTUs per pound or greater in terms of the differential. So those are the different control configurations. Next, we're going to talk about the wiring for each one. The first one is our single dry bulb. So in general, in order for the base economizer controller to be working, the following need to be wired. Otherwise, it's not going to work. Your supply hot, which is your R, your supply common, which is your C, your Y1, which is your stage 1 cooling, Y2 is your stage 2 cooling, G is your fan signal, CC1 is your compressor 1 mechanical cooling circuitry. You need your outside air temperature, supply air temperature, your actuator 1, which is your actuator supply common, actuator 2, actuator supply hot, actuator 3, which is your actuator control output, and your actuator 5, which is your actuator feedback signal. So all of those being wired, you're able to now wire it for each control type. And you also need to remember that you need 2-stage thermostats. The reason being, your first stage is going to be your economizer. Your second stage would be your mechanical cooling helping the economizer. If you do already have 2 stages in terms of compressors, you would have that anyway. Okay, so you can see we have all the mandatory inputs that we talked about. Additionally, we have our W1 here, as well as our CC2. So those are usually optional. Your W1 would be wired for a heat pump, and your CC2 is wired for a second stage of cooling for your compressor. There's a few things to note for this setup and the setups that we're going to be talking about. If the thermostat is not equipped with an occupancy control, the fan on output needs to be wired to the G. Your W1 has to be wired for heat pump operation if your conventional thermostat is used in conjunction with a defrost board. If your thermostat and RTU use an O/B control reversing valve position, your O/B need to be wired to your W1. If it's not a heat pump and it's a conventional unit, you can still wire your W1 if you want to record your heating operation hours. And if you wanted, your actuators can actually be mounted in parallel if you wanted to do multiple. And you would do that with your Act 1, Act 2, and Act 3. And your Act 5 would be wired directly to your outside air damper in order for it to work. We'll talk about that a little bit later. Moving on to our differential dry bulb, pretty much the exact same thing as our single dry bulb. The only difference is now we have our return air temperatures wired in. Next up, we have single enthalpy, very similar to single dry bulb. The difference being we have our outside air humidity as well as our temperatures, right? And then you have your power supplied to the humidity sensor here. Okay, last but not least, we have our differential enthalpy. The only difference here is we also have our return air humidity sensors. And it's important to note that the return air enthalpy sensor and the outside air enthalpy sensor, they're both supplied with the 24-volt power from the R on the zip base module. You can see that here. They're actually wired in parallel. Okay, as discussed, we're going to talk about the multiple actuators. For this instance, you have your exhaust air damper, return air damper, and your outside air damper. They're all wired in parallel for your Act 1, Act 2, and Act 3 terminals on the Zip Economizer controller. And then again, like we said, your Act 5 goes directly to the outside air damper output. Okay, so that's for the base economizer. There's some modules that you can add on that we're going to talk about. The first one being the energy module. So for this one, you have the option of demand control ventilation, indoor fan 2-speed control, remote diagnostic alarm notification, power exhaust fan, an override for your damper positioning, and a pre-occupancy purge. So here's the wiring for that. Here's your CO2 sensor wiring, your indoor fan low-speed relay or a VFD enable, your power exhaust fan relay. This is for your remote potentiometer, in case you wanted to manually set that damper position. And this is for your purge contact. All right, our next module is the communication module. It is for communication interface with BACnet, that's here. And you could also wire it for alarms. They could be anything you want to be tracking, such as your temperature sensors. This one's the simplest of the wirings. And lastly, really quick, in terms of our temperature and humidity sensors for either your outside air or return air, it basically works in every single orientation, whether vertical, bottom, or upside down. The only orientation that doesn't work is here. So as long as you have it mounted in any of these positions, it should work. Again, this position will not work for the temperature and humidity sensor install. That concludes our video for the wiring of the Belimo Zip Economizer. As I said, we're also going to be presenting a video showing a live demonstration of the setup for the controller. Look forward to teaching you again. Take care.